All right, we're going to be solving algebraic equations in modulo 7. The first equation we're going to work on is 4 times x minus 1 plus 6 is congruent to 4 mod 7. So the first thing to note about mods are when it's in mod 7, that means the number can never there can never be a numeral that's larger than 6, because once it hits 6, it goes back again and starts over. Nothing can go over the number 7. So we're no longer in base 10, we are in mod 7. The other thing to note as well is we're looking for congruency, so we're not looking for and something that is equal to something else. So we'll walk through each when it's something that is a little different than our normal understanding of algebraic equations. But one thing that's important to note about how it's similar to algebraic equations is you can still, when simplifying these equations, you still use the same rules that we do in normal algebra. So this in particular, the first step, using order of operations, we can distribute the 4 into this part of the equation. So it's now 4x minus 4 plus 6 is congruent to 4 mod 7. The next step in a normal equation would be to take the 4 and the 6 to add them together, the negative 4 and the 6 to add them together to get 2. Plug that back into the equation to get 4x plus 2 is congruent to 4 mod 7. Next step, of course, is to subtract 2 from both sides and get 4x is congruent to 2 mod 7. So this equation's been great so far because it hasn't ever made us go above 6. So we haven't had to worry about how to change the mod, the number into mod 7. We will not have this great of luck in the next equation, but I'll show you how it works in the table. So now that we have 4x is congruent to 2 mod 7, we're going to use our table, which is our multiplication table. This is just explaining how the numbers 1 through 6, when multiplied together, and what they look like. As you can tell, again, there are no numbers above the number 6. That doesn't mean that you multiply them any different, but it's just how you finish the problem. So as you can see, 1 times 1, 1, 2 times 2, 4. So up to 6, it's the same. But when you get to something like 5 times 5, when you actually multiply them, it's 25. But in mod 7, what you do is you take the closest multiple to 7, or closest multiple of 7, to the number you're looking for without going over it, and you subtract the product from that multiple. So 5 times 5 is 25, closest multiple of 7 is 21. Therefore, the leftover numbers that you have are 4. So you have 3 groupings of 7 to get 21, and then you have 4 left over from that 25. So that's how that works. And that works with all of these numbers, 36 being close to 35, so now that one would be 1. So for our problem that we had was 4x is congruent to 2. So what you do is you go on your A and you look for 4, and we have the product of this equation being 2. So if you go all the way over to here to find 2, we can find out that our x, or b in this case, is 4. So plug that back into our equation. We find that x is congruent to 4. Next problem is 103x plus 34 is congruent to 1 mod 7. For any tell, we're going to have a couple problems with this one because 103 and 34 are not in mod 7. First step for this is going to be subtracting 34 from both sides and getting 103x is congruent to negative 33 mod 7. One thing that we haven't mentioned yet is in this next part, when I am going to convert them into mod 7, I don't have to equally convert them on both sides. Because they're different sums, I'm going to have to find different multiples of 7. So they don't have to be the same, because in multiples of 7, or in congruency, it's not what something is equaling, it's what's closest in congruency. So 1 is just as congruent to 14 as it is to 28, as it is to 7, as anything that's that set of multiples of 7. So that's how that works. So the closest multiple without going over of 7 is 28. So we're going to take the negative 33 and add 28 to it. We're going to get 103. It's congruent to negative 5 mod 7. But in mod 7, we don't want to have a negative number if we're going to be solving this equation, so we're going to add another 7, which is fine, because again, negative 5 is just as congruent to 7 as 2. So it's going to be 103x is congruent to 2 mod 7. The other side of this equation is going to be a little bit trickier, because many people might know what the closest multiple of 7 is to 103. Unfortunately, I don't off the top of my head. So if you don't know, like we knew in this problem, we knew that 28 was the closest multiple, because it's a low enough number that I knew those common factors. But up here, I'm not sure what 103 is. So the other way you can always do the problem as well is if you just minus 7 as many times to get down to a number that's acceptable in mod 7. So we did enough times, and we subtracted 7 14 times to get a number that's acceptable in mod 7. That number, it was 5x is congruent to mod 7. Therefore, now that we have a small, nice equation like that, we are going to use our table again and go look for the 5. And then we know the product is 2. Go all the way over here, find our product being 2. Then we can look right up here, and our x, or b, is 6. Therefore, x is congruent to 6 mod 7. And that is algebraic equations in mod 7.